All right, today we're going to look at a really cool visual tool for understanding probabilities. It's the probability tree. It's a really great way to map out all the possible futures for a situation and see what the odds are for each one. So if you've ever wondered about a question like, what's the chance of catching two green lights in a row when you're driving somewhere? Or if you remember our previous question, getting matching socks when you pull them out of a drawer in the dark, that's exactly the sort of thing we can solve with the probability tree. Let's look at a couple of bits of vocab. So we're talking about sequential events. That just means things that happen one after the other. And the order for this does matter. Like if you flip a coin, you roll a dice, that's the order we're talking about. Then there's a probability tree. It's just a diagram. It just helps you lay out all the possible outcomes in order. It shows you the sequence of events. The end of every branch is a particular outcome. So we have the dots, and that's where we'll put the step or the event that we think is going to be happening. And from this, if there's multiple things that can happen after that, we'll have multiple branches leading out from it. For instance, if we got two possible outcomes afterwards, like first we toss a coin, and next time we toss another coin. If we got a heads the first time, we got two outcomes for the second event. And where the question marks are, we'll be putting the probabilities. And these trees can look like anything. They'll branch out, and then those branches will have branches if there's multiple different steps in the sequence. And the key thing is that at the end of it, if you want to find the probability of one branch happening, all you have to do is pretty simple. All you have to do is multiply along those paths to get to the end of that branch. Okay, here's an example. Let's say we're picking marbles from a bag. We're going to have 5 red marbles and 3 blue ones. We're going to reach in, and we're going to pull up 2 marbles, one after the other. But the key thing is we're not going to put the first one back. This is without replacement. So the very first draw, we've got 2 options, red or blue, and we're going to lay that on every step. Second option, we have red or blue again. Now, how many marbles do we have? We've got 5 red and 3 blue. So that's 8 total marbles. So we're going to put 8 on the bottom of our fractions for our first step. 5 out of 8 for red marbles. That's the probability of getting a red marble for your first pick. And 3 out of 8 for the blue marbles. The chance of getting a blue marble, 3 blue marbles out of 8 total marbles. And we should check. 5 out of 8 plus 3 out of 8 equals 8 out of 8, which is 1. So here we go. We'll label those on the first step. Now, if our first marble out is blue or red, what does that do to the odds going forward for our second draw? Well, if the first marble was red, now we've only got 7 marbles left, and 4 of them are red. Still, there's 3 blue marbles, so that's 3 out of 7. However, if we picked a blue marble first, we're now looking at 5 red marbles still, but only 2 blue ones. So we can see that our probabilities for step 2 change depending on what we picked first. So the odds for the second draw literally change based on what we did the first time. Conditional probability. Okay, so we have our first draw, then we add paths, and then we add on the probabilities for the second draw. That's how we build the tree. Notice that denominator will change. And then to do our calculation at the end, all we have to do is multiply along those branches. So here if we multiply along, 5 over 8 times 4 over 7, for all of these particular ones, this isn't always the case, but for all of these, they're all going to multiply to a fraction out of 56. And if we check all those probabilities, of course, they need to add up to 1, or 56 out of 56, which is 100%, which means we haven't forgotten anything. So if I wanted to ask you a particular question, like a red, then a blue, that's 5 out of 8 times 3 out of 7. So the main thing here, if we unscramble these probability trees, is that we can make a simple visual map to understand every possible path for every possible future. What sort of probability events do you think you could put into a probability tree?